Hello everyone, I am Divya, your math facilitator. In this video, we shall discuss the solutions of exercise 11.4 of our trigonometry chapter. I have discussed the concepts of this chapter very clearly in the earlier videos. If you have missed watching it, then I'll just pin up here in the I button. You can click on the I button and watch those videos too. Now this exercise 11.4 is completely based on trigonometric identities. I have discussed how to derive the identities also, and I discussed a trick of how to remember the identities. So don't miss out those videos. And now let's get into the session. So the first problem is you have to evaluate the following. Okay, you have first bit 1 plus tan theta plus secant theta multiplied by 1 plus cot theta minus cosecant theta. So the tip which I'm giving is wherever you find tan, secant, cot, cosecant, reduce it to the lowest form, that is sin and cos. Okay, so wherever you find tan, secant, cosecant or cot, reduce it to sine and cos. Okay, so which means, so this I can write as 1 plus tan theta, I can write it as sine theta divided by cos theta. Okay, plus secant I can write as 1 divided by cos theta. Okay, multiplied by, this is 1 plus cot theta, I can write it as cos theta divided by sine theta, minus cosecant is 1 by sine theta. Okay, so nothing but you are reducing tan, secant, cot, cosecant into sine and cos. Okay, so in every problem we are going to do the same thing. So this is equals to, let us take LCM. Okay, so here you can see this denominator is cos theta, and here you don't have any denominator, so it is like 1 divided by 1. Okay, so the LCM you get is cos theta. Okay, here you don't have anything, so it is 1 into cos theta is cos theta, plus denominators are same, so this is sin theta, plus here you have 1. Okay, and here also similarly taking LCM, here you have sin theta in the denominator. Okay, here you have sin theta plus cos theta minus 1. Okay, yes, so after taking LCM, this is what you get. Okay, so now here you can see these two are multiplication, these two terms are in multiplication. Okay, so let me write them together. So this is cos theta plus sin theta minus 1 multiplied by sin theta plus cos theta minus 1 whole divided by cos theta into sin theta. Okay, so these two terms are in multiplication, so I'm just taking them together. Okay, under single numerator and denominator. So now here you can see this is like a minus b into a plus b form. Okay, here this is nothing but here you have plus, isn't it? This is like a plus b into a minus b. Okay, where a is nothing but cos theta plus sin theta is a. Okay, so this is a plus b multiplied by a minus b. Okay, so what is the formula? It is a square minus b square. We know that a square minus b square is nothing but a plus b multiplied by a minus b. This identity we know, isn't it? Algebraic identity. So here also you can see it is like this complete thing is a. Okay, so cos theta plus sin theta is a. So this is a plus b into a minus b. Okay, so what is the formula? You can write it as a square minus b square. Here a is cos theta plus sin theta. Okay, so let us write here. So this is cos theta plus sin theta square. Okay, a square minus what is b? B is nothing but 1. Okay, so minus 1 square divided by, what is the denominator you have? You have cos theta sin theta. Let us write it here, cos theta sin theta. Okay, now using our trigonometric identities, we know that cos theta plus sin theta whole square is what? So it is like a plus b whole square formula. So you can say it is a square plus b square plus 2ab. Okay, minus 1 square is nothing but minus 1 divided by, you have cos theta multiplied by sin theta. Okay, Now using trigonometric identity, you know cos square theta plus sin square theta is 1, isn't it? So this becomes 1. Cos square theta plus sin square theta is 1. Plus you have 2 sin theta cos theta and you have minus 1 divided by cos theta sin theta. Okay. So here you can see, so using trigonometric identity, you got cos square theta plus sin square theta is 1 plus 2 sin theta cos theta minus 1. Now what is plus 1 minus 1? Plus 1 minus 1 gives you 0. Okay. So plus 1 and minus 1 gets cancelled. Here you have 2 sin theta cos theta divided by here cos theta sin theta or sin theta cos theta. Both means the same. Okay, here sin theta gets cancelled, cos theta gets cancelled, and the answer you have is 2. Okay, so just transfer the tan, secant, cot, cosecant into simple sin and cos. Okay, we know tan theta is sin theta upon cos theta, secant is 1 by cos theta, cot is cos theta by sin theta, and cosecant is 1 by sin theta. And now taking LCM, this is what you have. Here you are going to use a plus b into a minus b identity. Okay, so using that, you get it as cos theta plus sin theta whole square minus 1 square. Now again this is a plus b whole square form. So a square plus b square plus 2ab. Okay, minus 1 you have here. Okay, so now again cos square theta plus sin square theta is 1. So using trigonometric identity, this is 1 plus, now this complete thing is 1. Cos square theta plus sin square theta is 1 plus you have 2 sin theta cos theta and minus 1. Okay, so plus 1 minus 1 gets cancelled and you have 2 sin theta cos theta divided by cos theta sin theta. These two gets cancelled and these two get cancelled and the final answer is 2. Okay, chalo, let us move on to the next question. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Now in the previous problem I told you wherever you have tan, cot, cosecant, secant, you will change it into sin and cos. Here you have sin and cos. Okay, it is in the lowest form. So we shall simply expand this. This is like a plus b whole square plus a minus b whole square. So what is a plus b whole square? A square plus b square plus 2ab, isn't it? So we know a plus b whole square is nothing but a square plus b square plus 2ab. Okay, similarly, what is a minus b whole square? It is nothing but a square plus b square minus 2ab. Okay, so this is like a plus b whole square. This is like a minus b whole square. So let us use these two identities and write it here. So sin theta plus cos theta whole square is nothing but sin square theta a square plus cos square theta plus 2 sin theta cos theta. Okay, okay, this you have expanded. Okay, you have plus. Okay, now here's a minus b whole square. This is like a minus b whole square. For that, you know, it is nothing but a square plus b square minus 2ab. Okay, so let us expand. So this is a square sin square theta plus b square is nothing but cos square theta. You have minus 2ab minus 2 sin theta cos theta. Okay, this is what you get. Now just see, now sin square theta plus cos square theta is 1. So this complete thing is 1 plus you have 2 sin theta cos theta. Okay, plus again sin square theta plus cos square theta is 1. So this is 1. You have 2 minus 2 sin theta cos theta. Okay, so plus 2 sin theta cos theta minus 2 sin theta cos theta gets cancelled. Okay, plus 2 minus 2 becomes 0 and 1 plus 1 gives you 2. Okay, so the final answer is 2. Simple, use a plus b whole square and a minus b whole square, and one trigonometric identity we are using is sin square theta plus cos square theta is 1. Okay, let us move on to the next one. Secant square theta minus 1 multiplied by cosecant square theta minus 1. So this is direct identity. We know that secant square theta minus tan square theta is 1. Okay, so from this I can write secant square theta minus 1 is taking this minus 1 to other side. So this is minus 1. Secant square theta, you have plus 1. Taking this plus 1 to other side, it becomes minus 1. Minus tan square theta, if you take to the other side, becomes tan square theta. Okay, now you also know another identity. What is it? Cosecant square theta minus cot square theta is 1. Okay, similarly the same identity by just transposing cot square theta minus cot square theta to RHS, what do you get? You get cosecant square theta minus 1, take 1 to LHS, so it is minus 1 is equal to, this becomes plus cot square theta. Okay, so using these two identities, I can see that secant square theta minus 1 is nothing but tan square theta. That means this is tan square theta. Cosecant square theta minus 1 is cot square theta. This is cot square theta. Okay, so let us use these two identities and write it here. So substituting, I get this is nothing but tan square theta. Secant square theta minus 1 is tan square theta. Cosecant square theta minus 1 is cot square theta. Okay, so this is tan square theta multiplied by cot square theta. We know that cot is nothing but the reciprocal of tan. Okay, so let me write it. Cot square theta is nothing but 1 by tan square theta. Okay, cot is nothing but the reciprocal of tan, isn't it? So tan square theta gets cancelled and the answer is 1. Okay, so simple, tan is not, cot is nothing but the reciprocal of tan. Okay, so cot theta is 1 by tan theta, so cot square theta is 1 by tan square theta. Okay, so tan square gets cancelled, you have 1. Let us move on to the next one now. So show that cosecant theta minus cot square theta is equals to 1 minus cos theta divided by 1 plus cos theta. Okay, so here also you have cosecant cot. As I told you, you will change it into sine and cos. Okay, so let us take the LHS first. What is the LHS you have? You have cosecant theta minus cot square theta. So cosecant theta minus cot theta whole square. This is what you have. Okay, so simply just convert this to sine and cos. So this is nothing but cosecant is 1 by sine theta. Yes, minus cot is nothing but cos theta by sine theta whole square you have. Okay, just take LCM. So taking LCM, denominator is sine theta, both are like fractions. So sine theta is the LCM. Here you have 1 minus cos theta whole square. Okay, so this is nothing but just separate the power. So you have 1 minus cos theta whole square. Okay, divided by 1 minus cos theta whole square divided by, you have sine square theta. Okay, just I'm separating the powers to numerator and denominator. So this is 1 minus cos theta whole square divided by sine square theta. Okay, but we know that we know one identity. What is it? Cos square theta plus sine square theta is 1, isn't it? You know this. Okay, cos square theta plus sine square theta is 1. Okay, so from this, if I just send cos square theta to other side, okay, if I transpose cos square theta to RHS, so what does it become? So it becomes sine square theta is equals to 1 minus cos square theta. Okay, so what is the value of sine square theta? I'm getting it is nothing but 1 minus cos square theta. So I just want to substitute this here. Okay, so this becomes 1 minus cos theta whole square divided by sine square theta is nothing but 1 minus cos square theta. Now why am I just substituting sine square theta as 1 minus cos square theta? Because here you have to prove that this RHS is of the form only cos thetas you have in RHS. Okay, so that means I don't want any sine theta or any other trigonometric ratios. I want only cos. So I'm just transferring this sine square theta to cos square theta using the identity we have. Okay, now just see, this is like a square minus b square. It is like a square minus b square. Okay, so a square minus b square is nothing but a plus b into a minus b, isn't it? So using this identity, so this is nothing but 1 minus cos theta whole square divided by, this is like a square, 1 you can write as 1 square, isn't it? So 1 square minus cos square theta, so you can write as 1 plus cos theta a plus b, it is a plus b into 1 minus cos theta. Okay, a plus b into a minus b. Okay, now here you see in this step you have 1 minus cos theta whole square, and here in denominator you have 1 minus cos theta. So this cancels one time. Okay, it is like in this way. See, a square divided by a. If you take 1 minus cos theta, if you consider it as a single unit a, So it is like a square divided by this 1 minus cos theta is a. So it cancels and you get a, isn't it? One time it gets cancelled. So similarly here 1 minus cos square theta, if you want you can write another step. So this you can write it in this way. Okay, taking another step. So directly you can cancel, but if you want to take another step you can do it. So this you can write as 1 minus cos theta into 1 minus cos theta. Why? Because it is like a square. As I told you, it is like a square. So a square you can write as a multiplied by a. Okay, so I'm writing it as 1 minus cos theta multiplied by 1 minus cos theta divided by, here in denominator you have 1 plus cos theta multiplied by 1 minus cos theta. Okay, this is what you have. Okay, so here you can just cancel 1 minus cos theta, 1 minus cos theta. So what is left over? You're left over with 1 minus cos theta divided by 1 plus cos theta. Okay, so the final answer is nothing but 1 minus cos theta divided by, so this is 1 minus cos theta divided by 1 plus cos theta, and this is nothing but the RHS value. Okay, so this is how you prove. Simple. So firstly take the LHS, so convert it into sine and cos. Okay, so take LCM. The next step is you will take LCM. Once you take LCM, so here you can see that in the RHS you have only cos theta. So I just want to convert this sine to cos using the identity. Convert it. Now you can see you can cancel one common term. It is like a square minus b square. So split it. It is a plus b into a minus b. Now this is like a square. You can write it as a into a. Okay, 1 minus cos theta into 1 minus cos theta. It is 1 minus cos theta whole square. So you can write as 1 minus cos theta into 1 minus cos theta. These two gets cancelled and you have 1 minus cos theta divided by 1 plus cos theta. Okay, let us move on to the next one. Here you have shown that under root 1 plus sin a divided by 1 minus sin a is equal to secant a plus tan a. Okay, so here how shall we do it? Firstly, let us take the LHS. LHS is under root 1 plus sin a divided by 1 minus sin a. Now the tip here is just see what is the RHS value. RHS value is secant a plus tan a. Okay, and here you see what is there in the LHS. You have 1 and sin a. Now what should I do to get secant a and tan a here in the LHS? So if you see, if you carefully observe, if I divide the entire numerator by cos theta, because I know 1 by cos theta is what? 1 by cos theta is secant theta. Okay, so if I divide this 1 by cos theta, I'll get secant theta. The second point is you have sin a here, isn't it? So sin a divided by cos a will give me what? It gives me tan a. Okay, that means if I divide these two things by cos, I will get secant and tan, which is there in my RHS, isn't it? So let me divide it and see. Okay, so we shall divide both the numerator and denominator by cos theta. Okay, so here you have cos a, angle is a, so we'll divide by cos a. Okay, so let us divide it and see. So here you'll just write divide both numerator and denominator by cos theta. Okay, here you have angle A, so cos A. Okay, so dividing, what will you get here? This is nothing but 1 plus sin A divided by cos A whole divided by 1 minus sin A divided by cos A. Okay, this entire thing is in root. Okay, yes. So now just see, separating the denominators, here you will get 1 by cos A, 1 by cos A plus separating the numerators and denominator. Okay, so this is sin A by cos A. Okay, similarly here also you will have 1 by cos A. Just I am separating the denominator to this. Okay, so this is sin A by cos A. This entire thing is in root. Okay, now 1 by cos A is nothing but what? It is secant A. Okay, 1 upon cos A is secant A, and sin A by cos A is tan A. So this is secant A plus tan A divided by, here you have 1 by cos A is again secant A. Okay, here this is minus. Just see, so this is minus. See, 1 by cos A minus sin A by cos A. Okay, so this is secant A minus sin A by cos A is tan A. So secant A minus tan A. Okay, and don't forget here this entire thing is in square root. Okay, so let us write the square root also. Okay, now just see here in the RHS what you have to prove, you don't have any square roots. Okay, that means here I should not have any square root. So almost we are close to the answer, but you are having a square root and a denominator. Now just let me separate the square roots. So this is for the numerator and denominator. Let me separate it. So under root secant A plus tan A divided by under root secant A minus tan A. So here you can see you don't have any denominator, okay, and you have secant A plus tan A, okay. So that means I should not have this denominator secant A minus tan A, I should not have. So you have learned rationalizing the denominator concept, isn't it? So how will you do that? We shall use that, okay. So this becomes under root secant A plus tan A divided by under root secant A minus tan A. Okay, so to rationalize, what will you do? You will simply multiply and divide with secant A plus tan A. Okay, because you have minus here in the denominator, you will multiply and divide by secant A plus tan A. Okay, this is rationalizing. Okay, so once you do this, you see it is under root secant A plus tan A multiplied by under root secant A plus tan A. Now if you consider this entire secant A plus tan A as some term A, so it is like root A under root A. So what is the answer? Root A into root A is nothing but root A square. Okay, so finally you get it as A, isn't it? So similarly, I'm just taking this as A. Okay, it is like root A into root A. So I can write it as under root secant A plus tan A whole square. Got my point? So simple. Compare it with this. It is like root A into root A, which is root A whole square. Okay, so you get under root secant A plus tan A whole square. Okay, so in the denominator, what do you have? In the denominator, you have under root secant A minus tan A into root secant A plus tan A. So it is like root A minus B into root A plus B. Okay, secant A minus tan A, secant A plus tan A, root A minus B into root A plus B. So this you can write it as under root A minus B into A plus B, under root A minus B into A plus B. So what is the formula? A minus B into A plus B is nothing but under root A square minus B square, isn't it? So let me write it here the same thing. So this becomes under root. So just compare it with this identity. So it becomes under root A minus B into A plus B. So that you can write as under root A square minus B square. Here A is secant square. Okay, A is secant minus you have B is tan, isn't it? So secant square A minus tan square A. Now tell me, do you have any identity with secant square and tan square? Yes, we have. What is it? So now see square and square root gets cancelled. So here you have secant A plus tan A in the numerator. Okay, divided by secant square A minus tan square A is 1, isn't it? So root 1 is what? It is 1. So secant A plus tan A divided by 1 is nothing but secant A plus tan A, which is nothing but our RHS. Okay, got my point. So this is how you have to think for this question. So firstly take the LHS. Here in RHS you have secant A tan A. So I have to think that you have 1. So 1 divided by cos will give you secant, and sine divided by cos will give you tan. Okay, so that is the reason I'm dividing the both numerator and denominator by cos. So once I do this, take LCM. So once you take LCM, the next step is you get it in this way, but you don't have any denominator here in what you have to prove. Okay, and you don't have any square root, so that means I have to rationalize the denominator. So multiplying and dividing by secant A plus tan A by secant A plus tan A. Okay, root secant A plus tan A. So here it is like root A into root A. So I can write this root A square. Okay, so divided by, now using this, it is like under root a minus b into under root a plus b. Okay, the square root I can take it as common, so it is root a minus b into a plus b. Okay, you have learned this side. Root a into root b is nothing but root ab, isn't it? So all the previous concepts you will be applying here. Okay, so using that, it is like root a into root b, root ab. Okay, now again this is a minus b into a plus b is nothing but a square minus b square. Okay, but here comparing what is a is secant a, b is tan a. So it is secant square a minus tan square a. Okay, and you have an identity for secant square a minus tan square a, which is nothing but 1. Okay, square root gets cancelled. You have secant a plus tan a divided by, this is 1. So secant a plus tan a is the final answer. Okay, let us move on to the next one. You have 1 minus tan square a divided by cot square a minus 1 is equal to tan square a. This is what you have to prove. Okay, so for this, simply convert all the tan and cots to sin and cos. Okay, so let us take the LHS first. LHS is nothing but 1 minus tan square a divided by cot square a minus 1. Okay, so this I can write as 1 minus tan is nothing but sin by cos. Tan square is sin square a by cos square a divided by cot is cos square a minus sin square a divided by sin square a minus 1. Okay, so simple, take LCM now. So this is nothing but cos square a minus sin square a divided by cos square a whole divided by, here the LCM is nothing but cos square a minus sin square a divided by sin square a. Okay, so now just see, this is nothing but cos square a minus sin square a divided by, you have cos square a. Okay, and let me send this to numerator, so it becomes it reciprocals. So this becomes sin square a by cos square a minus sin square a. Okay, so this reciprocals and you get sin square a divided by cos square a minus sin square a. Okay, so these two gets cancelled and you have sin square a divided by cos square a. Okay, this I can write it as sin a divided by cos a whole square. So this is nothing but tan square a. Okay, sin by cos is tan. You have a square. So this is tan square a. Okay. So let us move on to the next one. You have shown that 1 by cos theta minus cos theta is equal to tan theta sin theta. Okay. Now let us take the LHS part. So it is 1 by cos theta minus cos theta. So let us take LCM. So it is 1 minus, this is cos square theta divided by cos theta. Okay, here you don't have anything, which means it is 1. Okay, so cos theta and 1, LCM is cos theta. So here the denominators are same. So you take the numerator as same. Minus, you have right minus. Here you have 1. 1 in the denominator, isn't it? So you have to get cos theta. So multiply this 1 by cos theta. Similarly, numerator also will multiply by cos theta. Simple LCM concept you are just applying here. Okay. So once you get this, now we know that sin square theta plus cos square theta is what? It is nothing but 1. Sin square theta plus cos square theta is 1. Now what is 1 minus cos square theta? We use this, isn't it? So 1 minus cos square theta is sin square theta. Okay. So this is nothing but sin square theta divided by, here you have cos theta. Okay, now just see, so I want it as tan theta sin theta. RHS is tan theta sin theta, that means 1 sin theta you will have extra. Okay, so this sin square theta I can write it as, let me write it here. So sin square theta I can write it as sin theta multiplied by sin theta. Okay, it is like a square, you write it as a multiplied by a, isn't it the same thing? Okay, so sin square theta divided by cos theta you have. Okay, so let us write it here. Sin square theta divided by cos theta is nothing but sin square, I can write as sin theta multiplied by sin theta, just now I told you, divided by, you have cos theta. Okay, separated to 1 sin theta, so this is sin theta divided by cos theta multiplied by sin theta. isn't it? So sine by cos is nothing but tan. So tan theta multiplied by sine theta. So this is the RHS you have to prove. Okay. So simple, take LCM. Once you take LCM, just compare it with what you have to prove. You have tan theta into sine theta. That means this sine theta, if I split it as sine theta into sine theta, okay, it is sine square theta. Splitting it as sine theta into sine theta and just separating it one cos to one sine theta, so you get sine theta by cos theta into sine theta, okay, which is tan theta into sine theta. Okay, so this is how you have to think little logically depending on what you have to prove. Okay, so then you'll get the answers very easily. Do practice these problems once, and I'll meet you in the next video with the remaining problems. If you like this video, then don't forget to share this channel to all your friends. Leave your suggestions and comments in the comment section below, and don't forget to like this video and subscribe to the channel. Thanks for watching.